A steady video frame rate or frames per second is an important parameter in Android video processing and gaming. Timely capture of face recognition and facial reactions such as smile or eye movement detection depends on a steady video frame rate. In this video, I will share the frame rates at which OpenCV reads my video files. I actually traveled to locations in different parts of the world to record my test videos. I used the same smartphone to record these videos. By traveling to the places shown, I wanted to expose the smartphone to various recording conditions. Now, you might be asking, doesn't the frame rate of video capture depend primarily on the frame rate set in your camera? Yes, the camera decides the frame rate at which the video would be recorded. However, sometimes we have to first save the video captured by your camera to a storage device when your video processing can't keep up with the rate at which your camera is outputting the video. To do video processing in those situations, your OpenCV read function may have to read the video file from the storage rather than from the camera feed. The frame rate at which OpenCV reads these files is quite different from the one your camera recorded the videos at. And that's why it becomes important to make sure that OpenCV provides a frame rate that is useful for your application. Take a look at the tests and let me know if getting these kinds of frame rates is sufficient for your video processing needs or not. So how do we test the videos? We playback the videos on a Windows laptop and record the laptop screen on our smartphone. For this re-recording step, I use an app that integrates a Kiwi camera provider for Android and the Python implementation of OpenCV. I had to use this additional recording step as our Kiwi app was not yet ready when we recorded our original videos and photos. Next, I use OpenCV on the same Kiwi app to read the videos from its storage. I've written a small program with OpenCV which calculates the video frames per second. I've left a link in the description for that program. Now, let me share what I saw in our tests. This is a video of fast-moving scenery. For this one, mostly the frame rate stayed at around 133.97 frames per second and occasionally hit higher rates as seen on this histogram. This is a video of photographs stitched together. I tested this intentionally to try and generate comparatively lower amounts of information that OpenCV has to process for the video frames. My hypothesis is that OpenCV will achieve a relatively higher frame rate for this one because there is less information to process per frame. A normal video of fast-moving scenes can provide more information to process for OpenCV in video frames, which I think can slow down OpenCV frame rates. The frame rate was mostly around 144.43 frames per second. This is a bit higher than that of the previous video of fast-moving scenery. Do you feel that this confirms our hypothesis that OpenCV video frame rate is reduced when there is more information to process in the video frames? Please share your comments in the comments box below. This one is again of photographs stitched together. The frame rate was mostly around 144.39 frames per second, which is higher when compared to that of the video of fast-moving scenery I tested before. Until this point, I tested videos in 9:16 aspect ratio. Next, I tested a video in 16:9 aspect ratio. The frame rate was mostly around 149.31 frames per second, which seems to be the highest in all the tests so far. The video is that of a slow-paced scenery of a river cruise. The last video I tested here was that of a fast panning action of the camera. This video was recorded in 9:16 aspect ratio. The frame rate for this one was mostly around 146.26 frames per second, which I think is on the higher side. I thought the fast pan action would translate to fast motion in the video and comparatively lower frame rate, but I think the frame rate achieved here is on the higher side. Do you have recommendations for specific smartphone make or models to use for this type of testing? What smartphone brands and models would you use for your tests? Do let me know in the comments. Our channel researches these aspects and brings you our findings that can help save time and shorten learning curves for developers and decision makers when it comes to computer vision use cases on Android. To get more of this type of content, please subscribe to our channel and hit that notification bell so that you don't miss any of our content in this exciting journey of smart mobile development.